This is the key for our iTunes U practice test. We've not talked about a neutron type of decay, but if I'm looking at the above examples, I can, by process of elimination and checking my notes, I know that this is going to be a beta decay, I know that this is going to be alpha, and this is clearly gamma. So that would leave this to be a neutron. And again, neutron is N, and the only thing that changes is the mass when you're talking about neutrons, because that's the only thing that a neutron has. It has no charge or anything else. By looking back at my notes, I can answer the following questions. Nuclear decay with no mass and no charge. Again, looking at this over here is my example. That would be gamma. The only thing gamma changes is the energy. Basically, emitting an electron is the beta negative. Least penetrating nuclear decay would be alpha, and again, that is something that you would have to read in your notes. Most damaging would be gamma. Those are the energy waves where you need to wear lead aprons when you go to the doctor's office for x-rays and that sort of thing. Nuclear decay that can be stopped by skin or paper, again, that's the least penetrating nuclear decay. That would be alpha. Nuclear decay that can be stopped by aluminum, that would be beta. Again, that information is in your notes. In completing the following equations, again, the thing that you want to remember is that whatever you have on the reactant side, you have to have on the product side. So in this case, my mass is not changing. It's going to stay as 42. And here I want to have 20, because 20 plus a minus 1 is equal to 19. And I look on my periodic table, and that would be calcium. For number 12, I have alpha decay. So again, both my mass and my atomic number will be changing, and the same applies here. My reactants have to equal my products. Reactants have to equal products. So this here would be 235 and 92, and I would have to look that element up and find out that it is uranium. So as I continue on with problem number 13, I notice that my reactant here is Be, and my product is also Be, but we know it's undergone some kind of a decay process. Since neither the mass or the atomic number has changed, I know that that has to be a gamma decay. And then in number 14, I've started with uranium 92, and I end up with thorium 90. Both my mass, which is this number here, and my atomic number have changed. So I'm going to know that it's changed by 4 on the top and 2 on the bottom, and that is the alpha decay. This is just asking us to write the following decays that are given. So here I'm going to draw my arrow, and I know that calcium, it's telling me that this element is undergoing beta decay. I write my symbols for beta decay, and then I just do the math. And again, knowing that my mass isn't changing, so this will be 45, excuse me. This will remain as 45, and my atomic number is going to change. It's going to increase by 1, and I'd have to look on my periodic table to see that that is the element Sc. So again, 21 plus a negative 1 equals 20. For the second problem, it's undergoing an alpha decay, so I'm going to draw my arrow, write my symbols for alpha. Whoops, that's a little sloppy. And I'm going to be taking 94, and I know that I would be subtracting 2, so that would be 92. And 234 minus 4 would be 230. And I'd have to look on my periodic table to find out that that is uranium. Again, I could check my numbers by adding back, saying 92 plus 2 equals 94, and 230 plus 4 equals 234. My next problems are really focused on half-life problems. And, whoa, sorry guys if I'm making you dizzy here. Here what I'm going to be doing is trying to figure out how old an artifact is if 5 half-lives have occurred, and the half-life of carbon is 5,730 years. So for this problem, really, I'm just focused on two things. I'm focused on the half-life and the time. I'm not given an amount, and I don't really care about that. So both start with 0. 1 half-life is equivalent to 5,730 years. 2 half-lives, you have to double that, or add the 5,000. So that would be 11460 years. And I'm going to kind of keep drawing arrows so I don't lose my spot. 3 half-lives would be, again, 11460 plus 5730, and that will equal 17190. 4 half-lives, again, doing the same exact thing, adding on another 5,000. That'll be 22,920 years, and 5 half-lives would be 28,650. So my answer is that this artifact would be 28,650 years old. All right. In my final problem, number 16, I've got, let's see. Sorry if I'm making you guys dizzy. Here I have, again, I'm given 15 grams. They're asking me how much did I start with. After 3 half-lives, I'm left with 15 grams. So again, this is a little bit different. Half-life, I'm not given any time, so I don't need to worry about that. But I am given an amount. I'm not giving a starting amount, I'm giving an ending amount. So after 3 half-lives, this is what I'm left with. I'm left with 15 grams. So in this case, I'm going to kind of work my way back. And we know that the amount is always, if you start from the top, you're going to be dividing it. But if I'm starting from the bottom, I'm going to be multiplying it. So 15 times 2 is 30. 30 times 2 is 60. 60 times 2 is 120. That would be my starting material. I can double check this problem by kind of doing it the way I'm used to and saying, okay, 120 cut in half is 60, 60 cut in half is 30, and 30 cut in half is 15. So my answer for this problem is 120 grams. That's it.